All right, hello, beautiful people. Welcome to part 3 of your pre-test for Unit 5 in the IM3 book. All right, again, disclaimer, if I make a mistake, that's okay. I'm human. Just let me know so we can learn from my mistake. If you hear a loud bell or intercom, I apologize. We are on campus. And again, if you have any questions, let me know. So we're going to continue with number 6. Number 6 is solve each equation. Remember to check for extraneous solutions. Now, extraneous solutions is if you get an answer, but you plug it back into the original equation and it gives you the denominator of 0, which of course we can't have a denominator of 0. Therefore, the solution is extraneous, but we have to worry about that towards the end. All right. So the first thing you need to do is factor, because we need to know what we need to multiply by to get rid of our fractions. So I'm going to say 2 over x, that's already factored. 5x plus 30, I'm going to actually leave that for right now. I'm only going to worry about factoring my denominator first. So I'm going to pull out my GCF, which is an x, and I get x minus 4 left over. And then I get 6 over x. Let's zoom in so that way you can see a little bit better. There we go. Okay, so our objective whenever we're solving these is to get rid of our fraction. We don't want a fraction whenever we're solving it. So the easiest way to do that is get your LCD. So LCD, the way that I like to figure out what that is I'm looking at the first fraction and I know I need to cancel out with x. So what do I need to multiply by to undo this divided by x? Well, I need to multiply by x. If I had an x up here, that means this x down below would cancel out. Okay, and we're going to do that for the entire thing. So once again, I'm going to ask myself, what do I need in the numerator that would cancel out with this x times x minus 4? Well, if I'm already multiplying by x, then if I would have an extra x up top, then these x's would cancel. But I still need my x minus 4. And then same thing. What do I need in the numerator that will cancel out with this x in the denominator? What I need an x. Well, I already have an x, so I don't need to put another one there. Okay, so this is how it works. This is where the magic happens. I'm going to multiply every single term by my LCD, which is x times x minus 4. So that will look like something like this. 2 times x minus 4 all over x plus 5x plus 30 times x minus 4. Now you don't actually need to do this step. You can just do it in your head, but I'm gonna, for the purpose of this video, do this the long way. I'm multiplying every single term by my by my LCD. Using the wrong acronym. Okay, so here it is. And then because you have multiplication, you've multiplied this LCD in, you get to cancel. So these x's cancel out. These x's cancel out. X minus 4 cancels out with x minus 4. These x's cancel out. And, oh, caught myself making a mistake. We do not have an x minus 4 here. We only have an x in our denominator. See? So then what do we have? So I'm going to bring it up here. So this right here, again, if you've done this correctly, you should have 0 fractions left over. So I have 2 times x minus 4 plus 5x plus 30 equals to 6 times x minus 4. We do not have any fractions left over, and so our life is a little bit easier now. Okay, multiply everything through, add, combine like terms, so 2x minus 8 plus 5x plus 30 is equal to 6x minus 24. And again, our objective, because this is an equation, we want an answer of x equals a number. Okay, your variable equals a number. It could be multiple numbers, but it should be some sort of one or multiple solutions. There should be a solution. You're not simplifying this anymore. You're actually getting an answer, getting a solution. Okay, combine like terms. 5, 6, 7x plus 20, what is this, 22, is equal to 6x minus 24. I'm going to subtract 6x to both sides. Now we're back in like integrated math 1, algebra, pre-algebra, combining like terms. So we have x plus 22 is equal to 24. Subtract 22 both sides. Ooh, I'm running out of room. X is then equal to 2. Okay. And then let's see if any of them give us an extraneous solution. So then we have, let's see here real quick. Let me make sure that I've done my math correctly. Oh, excuse me, my light turned off. There you go, and we're back. All right, let's take a look here. So 2x, let's see if I multiplied this correctly. Again, I just want to double check my work, make sure that my answer does make sense. For extraneous solution, I'm going to zoom out here just a second. We're plugging the 2 back into the denominator. So if I plug in 2 here, that is not 0. 2 squared is 4. 4 minus 4 times 2, that's 8. That is not 0. And then 2 is not 0 here as well. And again, I'm going to double check and make sure I've done this correctly. My LCD is x times x minus 4. So if I multiply that, I get x times x minus 2 times x minus 4. Here I get, if I multiply everything out, these cancel out. Good. And then this one here, my x's would cancel out. So what I would have is just x minus 4. Double checking my work here. Let's see. 2 times x minus 4, that's 2x minus 8. 5x plus 30 remains the same. And then 6 times x is 6x minus 24. 6 times 4 is negative 24. Okay. And, ooh, I believe I made a mistake here. So this is really good. This is an example of why you should always double check your work. So my 2 is completely wrong. And if you caught my mistake, I'm very happy. And if you didn't, that's okay. That's why we go over our work. Okay, so this here should have been negative. When I crossed this out, I accidentally made it look like I crossed out my negative. So that made me think of 24 is positive, but 24 is in fact negative. So then x is not equal to 2. X is in fact equal to negative 46. And again, when we plug that in back into here, still does not give us 0, so it is not an extraneous solution, so there are no extraneous solutions. No extraneous solutions. You don't actually need to write the no extraneous solutions, just state what they are if there are extraneous solutions. But if there's no extraneous solutions, then you don't have to do that. All right, let's move on to number 7. Write a polynomial function of least degree in standard form, which is expanded form, given the zeros below. So you are given zeros and you're asked to write a polynomial function. So the first thing you need to identify is if you have a complex root, you always have a conjugate. And what that means is it changes the sign between your two terms here. So do you see how this is a plus? That means you have a minus here. Both of them come as a pair. If you have a complex root, you will always have a conjugate. You can have 0 complex roots, or you will have 2 complex roots. You will never have 1, okay? So if you have a complex root, you will always have a conjugate. Now, conjugates only exist in complex roots. So like 3 is not a complex root. Therefore, it does not have a conjugate. So truly what you have is you have 3 zeros. You have 1, 2, 3 zeros. So when you're writing this out, you're always going to start with x minus, x minus, x minus. I'm writing this out and I'm leaving some room because I'm just going to plug in the number that I have here. And whenever you're dealing with like a complex root like this, always put it in parentheses and then distribute that negative. So what I have is x minus 3, x minus 1 plus root 3, and x minus 1 minus root 3. My recommendation, use the box method to multiply the complex roots because they are conjugates of each other. Things will cancel out, and we actually want things to cancel out. So I'm going to use the box method. I have x minus 1 root 3, and I have x minus 1 negative root 3. Using the box method. All right, x times x is x squared. Negative 1, that's negative x. This is x root 3. This is negative x. This is 1. This is negative root 3. This is negative x root 3. Ooh, almost ran out of room there. This is root 3. And what do we have here? Is a negative times a positive is a negative. And then root 3 times 3, that is, in fact, 3. Okay, so now, again, because they are conjugates, things will cancel out. So I have a negative x root 3 and an x root 3. I have a negative root 3 and a positive root 3. Looks like that's the only thing that cancels out. So we're going to be using the box method one more time because I still need to multiply it by x minus 3. So what I have here is x squared minus 2x. I can combine like terms here. So I have negative 2. And off to the side here, I have x and minus 3. So this is x cubed minus 2x squared minus 2x, negative 3x squared minus, what is this, 6x minus 6. And again, because they are not conjugates, if you are lucky, then things will cancel. If not, then things won't cancel. You're just going to have a longer polynomial. Okay, so let's add things up. So I have an x cubed. This is negative 5x squared. This is 6, 7, 8. Let's see here. Oh, this should be a positive. Do you see that? Catching all of my mistakes today. So this right here, I have a negative 3 times a negative 2, so this should be a positive. And then, so this is not negative 8. This is, in fact, positive 4x. And then again, this should be a positive 6. So write a polynomial of least degree. So your answer should be x cubed minus 5x squared plus 4x plus 6. All right. We're going to continue in the other part. I already lost count of how many parts there are, but we're going to continue on the next page. Thank you.